so this is part of what we're talking about between 8.1 and 8.2. Yesterday you did your notes on 8.1. Today we'll do notes on 8.2. And we're talking about representing a population with more than just 1 point. We're talking about representing an estimate for the population mean with a confidence interval. And so each of these dots represents 25 marathon runners. So we could actually calculate a confidence interval from any one of these points. And you can see that the shape starts to take on a little bit of that normal curve. It's not perfect, but the more dots that we put into place, you would start to see that take shape even more. So we have a given standard deviation. So go ahead and write that down. The standard deviation for the population in order to calculate a confidence interval has to be given. And you can recall from the previous question or from your notes yesterday that to calculate a confidence interval, we do our sample mean plus or minus our 2, which this value here you're going to see today is related to the fact that we want a 95% confidence level times sigma over radical n. And we all know that the n, the size of each one of these samples, was 25. So I'm going to calculate one confidence interval, and then I'm going to have you calculate an additional confidence interval based on your sample mean. So, Chloe, give me one of your sample means.
239.
Okay, so if x bar is 239, then I can calculate my confidence interval by doing 239 plus or minus 2 times 45.2 divided by square root of 25. So have this done. This will be kind of like an example. So the first thing you want to type into your calculator is this value here, which has a special name. Just this part of the formula is the margin of error. It's also E. When you've got it, raise your hand. Calculated 2 times 45.2 divided by the square root of 25, which we know is 5. Quinn?
Oh, sorry.
Okay. Listen. 18.08. 18.08. Okay. So 239 plus or minus 18.08 is going to be our confidence interval. So we'll go ahead and calculate then our lower bound and our upper bound by first subtracting 239 minus 18.08 and then adding 18.08. Raise your hand when you've got the lower bound. Start with the lower bound. Sheena, what do you get for the lower bound? 220.92. 220.92. And the upper bound? Sheena? 257.08. 257.08. So I can actually represent that on this dot plot as well. 220.9 right around 221, what do we write about here? And 257.08, so 257 right around here. And the X bar that we used was 239. So this is how we would represent on a dot plot a confidence interval. So we could say, I'm about 95% confident that the population mean is somewhere between these two values. So what I want you to do is calculate one more confidence interval for your sample mean on your paper. And then when you have it, come on up and mark it up here. And at the end, we'll have a bunch of confidence intervals.